So let's have a look at the second operation in the relational model, and we're going to look at selection today. Now, we looked at projection previously, which enabled us to choose particular columns from a relation, from a table. So we'll look at selection today. Here's an example of the projection operation from last week, from the last session, where we basically express projection in relational algebra and as SQL. And in this particular example, we were looking for 4 columns, emp number, ename, job and sal, so 4 attributes from the emp relation, from the emp table. So the way that we write that in relational algebra is we put the name of the relation in brackets, you can see the emp there, and then outside the brackets we have the 4 attributes, emp number, ename, job and sal. We put that small pi symbol at the front to indicate its projection. Now in SQL, the way that we do that is we use those 2 reserved words, select and from, and we know we're going to be using the emp table here, so emp goes after the word from, and then the 4 columns we're interested in, emp number, ename, job and sal, go there, and if we run that against the database we end up with this result set. So that's projection. To do particular rows we use this thing that's called selection, and that enables us to basically decide, we're sort of cutting that table into rows and columns, which particular rows we're actually interested in viewing, manipulating, whatever it is. Here's the formal definition of selection in relational algebra. And what it's suggesting here is that we will have a condition or a predicate, some kind of test that will run over our relation, and only rows, tuples or tuples, that actually satisfy that condition, that predicate, will be returned. I think this is easier to explain with an actual example. So let's look at this one here. Let's imagine that we had we've got this emp table, and what we're really interested in is the particular staff where the salary is greater than 25,000. So if you think about that, actually have a look at the salary column there. You can see we are particularly interested in those staff, for example, Byrne, Bird, Cox, Pollard, Rees, Parker, etc. Those are the ones where the salary is greater than 25,000. Now the way that we express that in relational algebra is like this. So we start off with the thing that we're going to put inside the brackets. That's the relation, the name of the table if you like, and in this instance we know that we're getting information from the emp table. So in here what we do is we simply write emp like that, and then outside the brackets we add our predicate, our condition. Now the way that we can express conditions and predicates is pretty standardized in computing and maths, and it's basically something that can be evaluated to be true or false once the names have been replaced with a value. And the way that we do that is we use things like equals, greater than, less than, and more complex expressions can be built using and, or, and not. So let's look at some of these examples here. Let's say that we were only interested in people whose job was manager, in other words, show me all the managers. Well, we would write this, we would write job equals manager. Now, because manager is a string, in other words, it's a series of characters, we have to wrap it up in double quotes. So we'd go job equals manager in double quotes like that. So everyone whose job would be evaluated is the job manager. If that's true, that means that gets included in our results set. It could be something involving mathematics. So for example, show me all the people whose salary is greater than 30,000. So we use that greater than symbol. And once again, every salary is evaluated to see, is it true, is it false? If it's true, it's recorded in our results set. That final one on this screen is an indication of where we're doing something slightly more complicated. We're going to use and. So both sides will have to be true for the result to be included in our result set. So it's only going to be included if their job is admin. Now admin is a string, so we're going to wrap it up in double quotes. And salary is greater than 25,000. And numbers we can just write down straight away. So just like in the example with 30,000, sal greater than 30,000 or sal greater than 25,000, we could just simply write the number down. So the rules here are that if it's a literal string, if it's a string, we have to wrap it up in quotes. If it's a number, we can just write it. And the kind of operations that we use are less than, greater than, equal to, less than or equal to, greater than or equal to, and not equal to. And we can use those complex expressions if we need to, and those can involve the reserved words and, or, and not. So let's go back to that example. Here we're looking at staff where the salary is greater than 25,000. So what we do is we simply, in that space there, we write the condition or the predicate. And so we're interested in the sal column, and we're specifically interested in where rows where salary is greater than 25,000. So we write that down like that. And if we could run that against the database, we would get our result set back, and it would look like that. So let's do another example. Say we wanted this one then. Say we wanted to see all the staff who are managers. Now, we just follow the process through again. We start off and we go, okay, which particular table are we interested in? Well, we know it's going to be the emp table, so we pop emp in there. We know it's going to be a selection. We're particularly interested in rows where they are managers. And if you think about the table, the column that contains that information is the job column, the job attribute. And what we really want to do is we want to test on that job column. And we want to say, is the job manager? And if we could run that against the database, it would return this as the result set. So that's actually the resultant relation from expressing this thing here, which is saying, select, show me where all the jobs are managers from the emp table. Okay, what about something like this then? Show me all the staff who are managed by employee number 734. So again, we go through the steps. What's the name of the particular table we're interested in? It's the emp table, so we pop emp in the brackets. Now we form our condition, our predicate. We basically go, we're interested only in the people whose manager is 734, and the attribute for the manager is this thing called MGR. So we're basically going to go MGR equals 734, like that. And if we could run that against the database, it would return this result set. One more then. What about show me all the people who are administrators who earn over £22,000? So step one, what's the name of the table? So we'd have a think about it. We go, oh yes, it's going to be the emp table. So we pop emp in there. Now this emp, this predicate's going to be slightly more complicated because it's going to have two parts. If we think about the condition here, we want to see staff who are administrators, and we want to see staff whose salary is over 22,000. So first of all, we know there's going to be an and in there because there's two parts to this predicate. There's sort of two sub-predicates, if you like. So we know there's going to be an and in the middle. We want to test on those people whose job is admin, and we want to test on those people whose salary is greater than 22,000. So if we express that, it will look like this. Show me all the people, show me all the rows where job is admin and salary is greater than 22,000. And we can run that against the database and we will get this result back. There it is. There's only one person who actually satisfies that criteria, where the job is admin and they earn over 22,000.